Okay, there we go. There's 1.1. I got that x is 14,13. Anyone else? Yeah, I did cos rule. You could have done sine rule, I'm sure. All right. But then you would have gotten the same answer. Yeah. Yes, that's fine.
Oh, because it's isosceles.
Radii, yes, it's it. Okay, guys, so I did opposite angles of a cyclic quad. They gave you this bottom angle, which was 118. So I used that to get A, which was the top angle. Because do we remember that opposite angles of a cyclic quad add up to 180? All right, so that's what you had to do to get angle A, which was the top one. Then I used angles, angle at center to get BOD, which obviously was the one at the center, which was 124 degrees. Now, again, guys, obviously we need to have the correct reasons, okay? You can't say, oh, this is a trig question. I'm not going to bother with reasons. Whenever you're using these theorems, you have to write down the correct reasons. And then in that triangle that we had, they gave us the one side was 8. And the other side was also 8 because it's radii. Okay, so you must remember that. So OD was 8 units because of radii. Then I used cos rule, but if you used sine rule, that's also fine. You would have gotten the same answer. Any questions on this one? Okay, 1.2. Oh, no, that's the wrong 1.2. No. Oh, it's here. Okay, I'll just show you this picture. Oh my goodness, gravity is working against me today. Okay, I'll just show you this picture quickly because there might have been, I don't know, I was trying to find like the shortest way of doing it. But I don't know if any of you maybe found a shorter way, and then we can talk about that. So for 1.2, we have to find x, right, which is that side over there. So I thought, okay, if I want to use sine rule maybe in this triangle, all right, because x is the side of this triangle, then I need the opposite angle there. Now we don't have the opposite angle, but guys, did you notice that AOC is a diameter? And we remember that a diameter always subtends a right angle, a 90-degree angle at the circumference of a circle. So this whole angle there is 90. So if that whole angle is 90 and that part is 16, then I can get that angle, the angle that's opposite side x, by doing 90 minus 16. Okay, so that's the first thing that I did. There, I did the calculation there. So I said that ADC is 90 degrees. We remember that the reason for that is angle in semicircle. Then I said ADB is equal to 90 minus 16, that one part of the angle, and I got 74. Okay, and I need this angle because it is opposite to the side that I'm trying to find. All right, whether I'm going to use sine rule or cosine rule, I always need the angle that's opposite that side. Okay, so that's done. Then I looked at what else I have here. I have this side in the triangle. Remember, I'm trying to use sine rule now. So I need that side. Now I have the angle opposite, but then I need another pair. All right, I need another side and angle that we know the values of. So they gave us this 15, but do we have the angle opposite 15? No. So that's what I then tried to find next. So I don't know if any of you found a shorter way of calculating it, but I noticed that we have angles in same segment over here, right? Do we remember if a chord is subtending multiple angles at the circumference of a circle, those angles will be equal. So I thought, okay, let's calculate that angle C because I have 44 and I have that is 90. So I can use angle sum in this triangle to get angle C, which I think was 46. Yes, right. I wrote that there. ACD is 46, angle sum in triangle. Again, you don't have to write down which triangle you're working in. It's just nice for me to keep track of what I'm doing when I do that. So then if this angle at C is 46, then the angle at B is going to be 46 because of angles in same segment. They both subtended by the same chord. And then I have everything that I need to use sine rule. Okay, so I'm going to say x over sine of 74 is equal to 15 over sine of 46. And then I can find x. All right, so there you go. There is the whole calculation. I then got 20,0. I'll just leave that up for a second. Was anyone able to find a shorter way or a different way to get x?
I did angle on 60 to get the 60 of that whole angle.
Okay, sure, yeah, all right, that sounds good as well. Okay, 1.3. Now in 1.3, I used cos rule to find the one angle, and then I did opposite angles of cyclic quad to get the other one. Why does this keep happening today? Okay, sorry, let me just show you. And the working is a bit, yeah, you might think that some of it is a bit redundant because the reference angle that you get for cos is actually the final answer, but we have to show all our steps. So we need to find x over there, that angle. Now, guys, we have the side that's opposite x, all right, that's opposite that angle, but do we have another pair of a side and an angle in this triangle? No, that's literally all that we have. We just have that one side. Okay, so we can't possibly use sine rule or cosine rule at the moment in this top triangle. What we do have in the bottom triangle, though, is they've given us all three sides. Now, I hope you guys remember that if you have all three sides in a triangle, you can use cos rule to find an angle. You just need to figure out which angle is actually going to help you then to find x. All right, because we could find either one of these, any one of these three angles. We could find A, or we could find B, or we could find C. Okay, it just depends on how we lay our cos rule out. Now, guys, if we're looking at this whole shape, it's a cyclic quad, right? And x is opposite angle B. So if I calculate angle B, and I then minus that from 180, because of opposite angles of a cyclic quad, I can get the value for x. All right, so that's how I started off. I decided I'm going to find angle B in this bottom triangle using cos rule. Remember, when you use cos rule to find an angle, you always start with the side that is opposite that angle. And that's the one that goes alone on its own. So the side opposite angle B is 10. So I'm going to write 10 squared is equal to everything else I then fill in. All right, so 3 squared plus 9 squared minus 2 times 3 times 9 times cos of B. Then I move things around and I solve for B. Okay, so that is what happened there. So that's my setting up of the cos rule. Remembering that if I'm finding angle B, I need to start with the side that is opposite angle B. Then this whole term is negative here. And 2 times 3 times 9 is 54. So it's negative 54 cos. So I move that over. It became positive 54 cos. On this side, I have 3 squared plus 9 squared. Then I must minus that 10 squared. So 3 squared plus 9 squared minus 10 squared is negative 10. To get cos on its own, I divide by 54. And I just simplified this. You didn't have to, but 10 over 54 is actually 5 over 27. But it's fine. You could leave it as negative 10 over 54, or you could write it in decimal form. Then remember, for cos, we look at where is cos negative? Which quadrants? 2 and 3. Can I have a quadrant 3 angle in a triangle? What do I do in quadrant 3 again? I say 180 plus. Can I have a 180 plus angle in a triangle? No. Guys, are you awake? Hey, not even half of you are making eye contact with me. All right, so here we disregard the third quadrant, okay, because it can't be in a triangle. So we get our reference angle and we do 180 minus that. So that is ABC. But then we actually have to do the same calculation again, because now x is going to be 180 minus ABC. All right, which is actually the same as the reference angle. But guys, you do have to show all of these steps. You do have to show, okay, you're finding angle ABC. Then you're using opposite angles of a cyclic quad to get x. Okay, so that's why I said it might look like some of these steps are redundant, because we actually had x up there. All right, but if you just say, okay, x is this, you might lose marks for not stating that that is angle B and we're using opposite angles of a cyclic quad. Oh, all right. Guys, I was going to start functions today, but at our meeting now, I've found out that no one else is starting functions today. So I'm going to give you another day to practice this stuff. All right. So I'm going to write down what you're going to work on now.
That is it possible for us to like actual examples.
From an exam.
It doesn't have to be a waste of things. If we look at the
Really right now. Yeah, I'm thinking now. Yeah, okay, I'll take a look now while you guys start working. I'll see if I can find something. Yes? Yeah, sure. Okay, guys, I want you to practice some more questions. So from exercise 9, which is the same exercise here. Just get my example. So it's the same exercise, so you can actually just carry on underneath this. I want you to do number 2, which is again working with values, but then we are also doing one where you're working with variables. Let me just check here. Number 4. And then from the revision exercise number 6. And guys, you can look at this as if you were actually studying for next week's test. The stuff will be in your test on Tuesday, along with trig equations. Remember, we did trig equations at the end of last term. Okay, so none of the other trig stuff, no proving identities, none of those like triangle questions. These triangle questions, right? But not the other trig stuff. You guys understand what I mean? Where you have to like choose a quadrant and draw it in that quadrant. So it's the trig chapter, only trig equations. None of the previous stuff. You've already been tested on that. That was in your previous test. Hold on. The trig equations and then this whole chapter. Haley? Yeah, so yesterday, yes, in an equation, definitely. So remember the ones where it was like a sine squared and you had to change it to a 1 minus cos squared. Yeah, so you need to be able to apply the identities, but we're not going to give you like prove that the left-hand side, right-hand side. We won't give you those types of questions. Okay, but you do need to be able to apply the identities even to these types of questions. Okay. All right, guys, get working on that, please. You can listen to music. Should I put number 2 on the board? Yes, just general solution, specific solution, and also those undefined, those things, yeah. Okay, guys, there is number 2. Number 4, unfortunately, is on the next page, but you can do 2 so long.